Okay, so in this lesson, we're going to look at graphing functions using reflections about one of the axes. So either the x-axis or the y-axis. So another transformation besides the shifting horizontally or shifting vertically, another transformation is reflection. So we can reflect a graph over either the x-axis or the y-axis. Now, when we go through this lesson, we're going to use the word a vertical reflection. So a vertical reflection reflects a graph vertically across the x-axis. Horizontal reflection reflects a graph horizontally across the y-axis. So vertical, x, horizontal, y. Vertical, x, horizontal, y. So what that means is this. So if I have this function, let's say this is the function f of x, okay? And it looks like this. So if I vertically, if I do a vertical reflection, so vertical reflection, remember vertical up and down, vertical reflection, you reflect it about the x-axis, okay? X-axis, y-axis. So vertical reflects it about the x-axis. So you got to think, you got to draw this the best you can in terms of making it look symmetric. So when you reflect this, let's say this point about the x-axis, you get this point here, right? This point right here, you get this point here, the same distance. See this distance, and then let's say this point here. So this point, that distance will be the same as I'm estimating, so it's not going to be that great, that distance. So when I reflect it about the x-axis, I get this graph. Okay, so this right here represents the vertical reflection of f of x. Okay, so vertical reflection of x. So f of x is reflected about the. Oops, I didn't draw this very well. This should have done this. Excuse me. Should not be going back down. So the f of x is a vertical reflection about the x-axis. All right, let me just quickly take this off. Okay. All right. Now, let's talk about the horizontal reflection. So when I take f of x and reflect it, and I do a horizontal reflection, horizontal mean going left-right. So that's going to be a reflection about the y-axis. So let's think about this point here. So this point, same distance here, right? All right, I didn't draw that very well, but it should be a little bit further this way. And let's say this point here. So if I have a point that's on the, so if think about what you're doing. So when you reflect this point here about the y-axis, notice what happens to the y-coordinate. So the y-coordinate stays the same, right? It is the x-coordinate that changes. So this x-coordinate becomes its opposite here. So you just reflect it about the y-axis, and this point stays the same. So if a point's on the y-axis and you do a horizontal translation, it stays there. So now that will look like this. All right, so this right here is going to be the horizontal reflection of f of x. Okay, so vertical. So notice when you do a vertical reflection, notice what changes and what stay the same. The x-coordinate stayed the same, right? It was a y-coordinate that changed. So notice that this y-coordinate, its opposite is right here. When you did the horizontal reflection, notice what stayed the same, what changed. So let's look at this point here. This point, when I reflected about the y-axis, so notice the y-coordinate stayed the same. It was the x-coordinate that changed. So this x-coordinate and this x-coordinate are opposites. Same thing here. When you reflect this point about the y-axis, the y-coordinates stay the same. It was the x-coordinate that changed. This x-coordinate and this x-coordinate are opposites. All right, so that's going to be important in a little while. All right, so that's the idea, though, about vertical reflection. So a vertical reflection is a reflection about the x-axis. A horizontal reflection is a reflection about the y-axis. Okay? All right. Now, let's look at this example. So I have this example here, f of x equals the square root of x. Okay? And I chose that example because there's some nice points here: 0, 0, 1, 1, 4. Oops, yeah, 4, 2, and then 9, 3. Correct? Because no square root of x. So the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. Okay, so that's the graph of the function f of x, which equals the square root of x. If I wanted to do a reflection about the x-axis, I want you to think about what's happening. So if I'm going to do a reflection about the x-axis, if I'm going to do a vertical reflection, notice that this point's going to stay the same because that point's on the do it in green. That point's on the x-axis. When I reflect this point about the x-axis, I get this point right here, right? So 1, 1 becomes 1, negative 1. 4, 2 becomes 4, negative 2. So notice the y-coordinate changes. The x-coordinate stays the same. 9, 3 becomes 9, negative 3. And so if you, oops, let me make sure I draw this correct. So when you reflect this about the x-axis, you get this right here. All right, so this right here is a reflection of this. All right, now I want you to notice what happened. Go ahead and label those points again. So notice this right here is 1, negative 1. This is 4, negative 2. And this point is 9, negative 3, correct? Right here, we had 9, positive 3, 4, positive 2, and then 1, 1. And then obviously 0, 0 right here. But I want you to notice when I reflected about the x-axis, what stayed the same, what changed? The x-coordinates stayed the same. What changed? The y-coordinates. The y-coordinates are opposites. 1, negative 1, 2, negative 2, 3, negative 3. Which, remember, f of x means the same thing as y, right? So f of x means the same thing as y. So it was that y-coordinate that changed. So what I want you to notice is this green graph, let's call it g of x, is going to be the opposite of the y-coordinate. So it'll be the opposite of f of x. And so that's that notation. Whenever you see a negative in front of f of x, in front of your function, then that's going to be a reflection of f of x about the x-axis. So notice 3, negative 3, 2, negative 2, 1, negative 1. That's that y-coordinate that changed. So g of x is the opposite of each of those y-coordinates. Okay? All right, now in terms of this, we also can rewrite it this way. So g of x will equal the opposite of f of x means the opposite of square root of x. So negative square root of x. Okay? Because remember, f of x is equal to the square root of x. All right, so that's how it looks. So this right here is negative square root of x. But it's important in a little while, that notation. So the opposite of f of x is a vertical reflection about the x-axis. That's important. So I'm going to write this down. So g of x, which is y, is going to be the same. Is going to let's say we had this is equal to negative f of x represents a vertical reflection of f of x about the x-axis. Okay, sometimes you'll see the word about, sometimes you'll see the word across. Okay, reflection of f of x across about the x-axis. All right, now let's talk about the horizontal translation. So I'm going to reflect this horizontal translation, remember, is where you take f of x and you reflect it about the y-axis. So let's go ahead and do that. I'm going to go ahead and use red to do that. So the origin stays the same. 1, 1, when I reflect it about the y-axis, becomes this point here, right? And then 4, 2, when I reflect it about the y-axis, becomes this point right here. And then 9, 3, when I reflect it about the y-axis, remember the distance, those distances have to stay the same. 4 units, 4 units, 1 unit, 1 unit. When I say distance, I mean distance from the, in this case, the y-axis. So 9,3, when I reflect it about the y-axis, becomes a point negative 9,3. And so this, oops, it should be going like this. So when I draw this red graph, that is the reflection across the y-axis of f of x. Now let's look at the points to kind of help us the same way it helped us with this. So this point right here is negative 1, 1. This point right here is negative 4, 2. And this point right here is negative 9, 3. So I want you to notice when you reflect something across the y-axis, notice the points. The y-coordinates stay the same. What changed? The x-coordinates. Those are opposites. 1, negative 1. Look at these two. 4, 2, negative 4, 2. The y-coordinates stay the same. What changed? The x-coordinates. The x-coordinates are what? Opposites. 4, negative 4. When you reflected about 9, 3 about the y-axis, the y-coordinates stay the same. The x-coordinates are opposites. All right, so what does that mean in terms of this notation? Here's what that means. Listen carefully. So I'm going to call this h of x here. So h of x will be, now remember, the y-coordinates stay the same. What was it that changed? The x-coordinate became opposite. So here's how it's going to look. It will be f of negative x. So the y-coordinates stay the same. So that's why you don't see a negative out here. But what changed? The x-coordinates. X, negative x. See this here? Negative 3, I'm sorry, negative 9, positive 9. Negative 4, positive 4. Negative 1, positive 1. So whenever you see f of negative x, that's a horizontal reflection about the y-axis. So let's write that down. So in terms of, see how we wrote it here? In terms of this, we could say that h of x is also the square root of negative x. All right? So negative x. So in place of x, you're going to substitute negative x. So that's what you see there. So f of negative x means the square root of negative x. So that's what you just found. Okay? Okay, so let's write this down here. So y equals h of x, let's say, is f of negative x represents a horizontal reflection of f of x about or across the y-axis. Okay? All right, now let's look at some problems where you're going to have to describe transformations. Okay, so for each of the following that you're going to see, we're going to describe the transformation or transformations of each of the graph of each of the functions that you see. All right, so now remember, we already talked about horizontal. See this horizontal? We talked about horizontal shifting, and we talked about vertical shifting. So you're going to see those problems as well in here. Remember, there's a negative now, but notice that that negative is on the outside of f of your function f. So when it's on the outside, remember when it's on the outside, that is going to be a, see right here, that is going to be a vertical reflection. So you're going to reflect it about the x-axis. Okay? And remember from the previous lesson, so you're always going to go from left to right. So we're going to do that reflection first, and then we're going to do the horizontal shift next. All right? So here's the answer. Okay, so that negative on the outside represents a reflection about the x-axis. So you're going to say this. So the answer, you're going to say reflect f of x across the x-axis. Okay? Then we do that horizontal shift. Now remember, remember, rewrite y equal negative f of x plus 3 as y equal negative f of x minus the negative 3. So remember x minus h, right? So you've got to be careful. So remember h here is negative 3. So remember counterintuitive. So h is negative 3. So we reflect, so that negative here represents reflection across the x-axis. And then we're going to shift it 3 units to the left. Then shift 3 units, so that represents a horizontal translation. So shift 3 units to the left. Okay, so that was number 1. Not difficult at all, right? A very simple process. Not difficult at all. Okay, let's look at this one. Okay, so here we have y equals negative f of x minus 5 plus 2. So how many translations do you see? Transformations do you see? Transformations. There are 3, right? There's the reflection across the x-axis. There's the horizontal translation, and then there's the vertical translation. Okay, so there are 3 transformations, and you always go from left to right. Always do the vertical last. Okay, so 3 transformations. So the answer, you're going to say reflect f of x across the x-axis. Okay, then shift to the, remember x minus 5, right? So remember our notation, f of x minus h plus k. So you got to write it as x minus. So it's already in that minus form, right? So this right here is your h right here. Okay? So shift to the, and h is positive 5. So shift to the right 5 units, and then here's your k, positive 2, and then shift up 2 units. Okay? So it's a very simple process, not difficult at all. Okay? Let's look at number 3. All right, so g of x, number 3, g of x equals f of negative x minus 3. Okay? So remember, notice that the negative, you see a negative x. So it's not on the outside, it's on that inside. So remember that's a reflection about the y-axis. That's that horizontal reflection. All right, so there are two transformations occurring. You have your horizontal reflection, and you have your vertical shift, your vertical translation. Okay, so the answer, you're going to say reflect f of x across the y-axis, and then shift, so that negative 3, remember that's k is negative 3, then you're going to shift it, then shift vertical, that's that vertical translation, so you can go down 3 units, then shift down 3 units. Okay? All right, so that is our discussion on graphing functions using reflections about either the x-axis or the y-axis.